Hi, I wanted to do a quick video on the homework problems in section 10.4. I'm not real pleased with the videos that are attached to the specific homework problems. It doesn't look like he's using the TI-84 to calculate this. So I thought I'd jump on, do a quick video and show you how to use the TI-84 to run a test on matched data. So section 10.4, we are looking at data that's paired meaningfully. So for example, if you're looking at a pre-test or a post-test, that kind of information, you want to see if there's a difference post as opposed to pre. So we're looking at matched pairs of data. So for example, if we look at question 1, are these matched pairs or are these independent samples? So we're comparing pre-test scores before training to post-test scores. That is data that is paired meaningfully. We're interested in, is there a difference in post as opposed to pre? So that is matched pairs. D, we're comparing the number of speeding tickets received by men and the number received by women. That is not matched pairs. Those are two completely independent samples. So it's not matched pairs, it's independent samples. So we would use some other test to run for that data. So that is independent samples. Part C, comparing pain levels for a group receiving a placebo to a group receiving a medicine. Again, those are independent samples. Those are two separate groups. One's receiving a placebo, one's receiving medication, two independent samples. And then lastly, comparing pain levels before and after treatment. Now we're looking at that before after situation. So we're probably looking at the exact same human being that's undergoing magnetic therapy. So we have that person tell us their pain level before they undergo the treatment, and we have them tell us the pain level after. So now we're looking at matched pairs, before after type data. Okay, so that's what you're going to be doing in this section. You're going to be running a t-test on the difference in your sets of data. So let's look at question 2, and I'm going to put my glasses on so I can read this. You wish to test the following claim, H sub A, at a significance level of alpha equals 0.02. For the context of this problem, mu sub D, so the differences in the means, is going to be post-test minus pre-test. And that'll help us put the data in our calculator if we know that we're looking at a difference that's post minus pre. Where the first data set represents a pre-test and the second data set represents a post-test. Each row represents the pre and post-test scores for an individual. So these are matched pairs. Be careful when you enter your data and specify that your mu1 and mu2 are so that the difference are computed correctly. So in other words, we want to make sure we get that post minus pre. So what I'm going to do, well, first of all, let's look at the null and alternative hypothesis. The null hypothesis, the status quo is that there's no difference in pre-post. So whatever we're doing is not making a difference whatsoever. The alternative would be that they are different, that the difference in post and pre is not equal to 0. There's actually some difference. And you could have the alternative hypothesis be less than or greater than. So maybe you're interested in post-test being greater than pre-test. Maybe we're looking at, you're taking a statistics class and you look at a pre-test, and then at the end of the semester, we do a post-test, and we would hope that post would be bigger than pre. We would hope that there actually is a difference when you take a statistics class, considering how much statistics you know. So we would hope that that would make a difference. So in that case, we might have post is greater than pre, or the difference between post and pre is greater than 0. So we can do that kind of thing with the alternative hypothesis also. Okay, but we're going to be doing a not equal to alternative hypothesis. So we're going to be doing a two-tailed test. All right, so here's my data. And I'm going to put each set of data in a list. And it doesn't matter which set of data you put in which list. It does matter how you take the difference, because we're interested in the difference being post minus pre. That's what they told us to test. So I put pre-test in list 1, and I put post-test in list 2. So I'm going to go run over to my calculator. And I'm going to go to my stat, my edit to get to my lists. And you can see that in L1, I have my pre-test information, my data, and in L2, I have my post-test data. Now, there's one of two ways you can do this. You can actually go in and calculate the difference post minus pre for each paired set of data. For each data pair, you can actually go in there and calculate it. So I can go in and I can take the 50.4, subtract the 61.7, and write that down. Or I could take the negative 6.4 and subtract the 54.9 and write that down. It's just way easier, especially when you got a long set of data with, I think there are 23 data sets in this data. So it's a lot easier to let your calculator do that. So we're going to let the calculator calculate post minus pre. So I have pre in L1 and post in L2. So what I do is I arrow up. So use my up arrow to highlight L3. And then I'm going to type in L3 equals L2 minus L1. So I'm going to find L2, so second 2, and you can see that it shows up down there at the bottom. L3 is equal to L2, and then I'm going to subtract from it L1. So I'm going to do second 1. And when I hit enter, it will actually calculate all the differences. So there are the differences in post minus pre. Okay, and I'm going to run a test on that set of data. So I'm running a t-test on the differences in these two sets of paired data. Okay, so I'm going to get out of here. So I'm going to exit my list. And I'm going to go run a t-test. So I'm going to go stat, tests, and I'm going to run a t-test, number 2. And I'm going to run a t-test on that data that I just put in. So that on my data, and mu sub 0 is 0 because we're assuming that there is no difference. What we're testing is there a difference? So the status quo is there is no difference between post and pre. And I have my data in L3 because that's where I did that subtraction L2 minus L1. I put that in L3. And we're running a two-tailed test because our alternative hypothesis is not equal to. It doesn't have to be. It could be less than or greater than, depending on what I'm looking at. What is my alternative hypothesis? I'm not equal to. And then we're going to go down here and calculate. Okay, so my test statistics, my t-score is negative 3.0569, rounded off to 4 decimal places. And my p-value is 0.0058 to 4 decimal places. And it also calculates for me the mean of the differences. The mean of the differences is negative 15.1565, and the standard deviation of the differences. So it does calculate that for me also when I run the test. Okay, so what am I interested in? I'm interested in that t-value because I got to go put that into my open math, and I'm interested in the p-value because the p-value is going to tell me whether I reject or fail to reject the null hypothesis. So let's go back. Right. So my test statistic, my t-value was what? Negative 3.0569. Okay, and my p-value, what did I get? 0.0058, 0.0058. So I'm going to hit enter just to do a quick check. I got that right. And now what do I do? Well, what was my alpha? my alpha is 0.02. So that p-value, 0.0058, is smaller, is less than my preset alpha. So it is less than or equal to alpha. And so what am I going to do? I'm going to reject the null hypothesis. If the p-value is less than the preset alpha, if the p is low, the null must go. So I'm going to reject the null hypothesis. So what's that mean? Well, if I reject the null hypothesis, my sample data supports the alternative. So my sample data is supporting the alternative that there is a difference. The mu sub d is not equal to 0. My data supports that. So there appears to be a difference in pretest and post-test. So which of these four is true? It would be the sample data support the claim that the mean difference of post-test from pre-test is not equal to 0. That's what it supports. There does appear to be a difference. Woohoo, got it right. Yay! So the rest of these are very similar. You're going to put your data in, and then you're going to look at how they state the question to determine what your alternative hypothesis is. So are you just interested in, is there a difference? Then it's a two-tailed, not equal to test. Are you interested in one being less than the other? Then the difference would be less than 0. Are you interested in one being greater than 0? Then the difference would be greater than 0. So that's how you would conduct the test. I hope this helps. If you have any questions whatsoever, please don't hesitate to reach out to me and send me an email. We can Zoom, whatever works best for you. Thank you. Bye-bye.